Alright, so this is the last problem, problem number 4 from the second part of the exam. And this one is a word problem, and this one reads, a homeowner wishes to enclose a rectangular garden plot having an area of 1,350 square feet. 3 sides of the plot will be enclosed with fencing that costs $3 per foot, and the decorative fencing for the side facing the street costs $6 per foot. What dimensions will minimize the cost of fencing? So this is a word problem dealing with minimize and maximum using the first derivative test. So what we want to do is first, I like drawing the picture, see what we have. So we have some rectangular garden or plot, and we can call this, well, we know, let's call this the x value. Now let's call this the y value. Okay, so then we know the area of a rectangle is x times y. And by the way, we want to find a function to be minimized, the constraint, which is the domain, and the x and the y values that are the minimum. Okay, so drew my picture, we have x and y. We know the area is x times y, but we know that the area has 1,350 square feet. Therefore, this implies that 1,350 is equal to x and y. So, definitely the constraint is going to be this. X times y has to be 1,350. Alright, so that's the constraint. We want to find the cost function now. So let's keep reading what they gave us. 3 sides of the plot will be enclosed with fencing that will cost $3 per foot. So let's say that, this side, and this side will be those sides, and this side is the street, so the street is here. So this side is where the street's at, and we have this, this, and this. Alright, so therefore, now we have the cost. So we have a cost function. So the cost, and the function, we want the cost function in terms of one variable, x, but right now it's not going to be just in terms of x. We'll have to do some substitution. So right now the cost is going to be 3 per foot on the, or so that's going to be 3y plus 3y plus 3y. So that's 9y. Plus, how much does this side cost? It costs $6 per foot. So that's a plus 6x. So now that we have cost, but now this function is in terms of y and x. Now, it would be nice if we have this function in terms of just one variable. Let's say x. So if I have it just in terms of x, I need to solve this equation here for x. So if I solve this equation for x, I get that x is equal to 1,250 divided by y. So that I have that, I can, let's solve this for y, sorry. I wanted to solve for y, not x. So I want to solve for y, so I can just plug it in here and have the whole function in terms of x. So we have y is equal to 1,350 divided by x. So since we know that, now we have the cost function in just terms of x. That's 9 times y. So that's that. Plus 6x. Alright, so now we have that. Okay, so let's go and, so that's our cost function. So cost function, restraint, that goes here, so that goes here. Just say 9 times all this. 6x. And then constraint is xy equals 350. Now I want to find x and y. So what I want to do is I want to take the first derivative using, so I got to do this first derivative test. Alright, so c prime is then equal to 9 times 1,350 is a constant, so I'll bring that outside and I have 1 over x. That's the same thing as saying x to the negative 1. So I use the power rule and I'll obtain negative 9 times that divided by x squared, and that's plus 6. The derivative of 6x is just 6. Okay, so we have that now. Now we want to equate this to 0. Alright, so first what I'm going to do is I'm going ahead and combine these two fractions. So I'm left with, so LCD is x squared, so I multiply this one by x squared. That's minus 9 times 1350 plus x squared. All that divided by x squared. Alright, so in order to find the so-called critical points, we need to equate this to 0. So, in order to find the critical points, we need to find when this rational expression is equal to 0 and when it's undefined. So, when we do that, we obtain 6x squared minus 9 times 1350 equal to 0. And we get that x squared is equal to 0. Let's write that here. X squared is equal to 0. So this implies that x is equal to 0. So we have this possible critical point. It's not going to be a critical point because if you plug it back into the cost function, 0 is undefined. So we can already scratch that out. It's not a possible critical point. So it's not a critical point. It's also possible, but not. Now let's look at this one. So here, we do some more simplifying. And the 6x squared is equal to 9 times 1350. Okay, so divide both sides by 6. So when we do that, we get that x squared is equal to 3 and 2. So we have 3 times 1350 divided by 2. Okay, but 1350 is going to be 5, so I can break this down and say this is 5 times 10 times 9 times 3. Okay, so 5 times 10 times 9 times 3, that's 1350. Just broke it down. Divide that by 2. Okay, but 10 is 2 times 5, so it cancels out the 2's there. So this is 2 times 5, so 2's cancel out. I'm left with 9, 9, and 25. So that's 9 times 25. And now if I take the square roots on both sides that I want to solve for x, I obtain that x is equal to the square root of 9 is 3, square root of 9 is 3, and that's 5. So that's 3 times 3, 9, and 9 times 5 is 45. So x is 45. Alright, so now we have x equals to 45. Now let's go ahead and solve for y. So that's our critical point. Really quick check. Let's erase this here. So if you look at, we have 35 here, 45, and we know it's in between 0 and 1350. So let's pick a test point here, 1. Let's pick a test point here, 46. And then we're going to see that this is going to be a minimum. This has to be a minimum. This has to go from decreasing to increasing to have a min. Alright, to check that, plug 1 into the first derivative. So the first derivative, I can plug it in here. If I plug in 1, I'll get a 6. I'll get a very big negative number. Plus 1 is still negative. So this is negative, so this is going like that. Alright, and now plug in the 46. Come here, plug in 46. 46 squared, huge number, times 6, another huge number, bigger than negative 9 times this, so the top is going to be a positive, and the bottom is going to be a positive. So we have positive, positive, so that's increasing. Alright, so we have that. So you can see that here's a minimum. So 45 is the minimum, because we want to find that minimize the cost of fencing. So that's 45. So if x is 45, how do we find y? We have the cost function here, so we can find what y is. So therefore, y is equal to c of 45, and that's going to be what? That's going to be 9 times 1350 divided by 45 plus 6 times 45. Alright, well this is going to be. Already calculated it, so that's going to be 30. So y is going to be 30. So then here we'll have 45, and we'll have 30 here. And that's it. That's all they asked for. That's the cost function, constraint, x and y. These are the x and y values that minimize the cost. Alright.